Warm welcome to this Telenor Connexion, Telenor IoT webinar on how does 5G fit into the future of IoT. Topic of today. 5G is the future, but IoT is of course part of it. And with me here today, I have Hjelte Janssons, Product Manager at Telenor Connexion. Welcome. Thank you. And my name is Martin Whitlock, CTO at Telenor Connexion. So we will try to guide you all through this interesting topic today. In a sort of a conversational mode, more than just presenting. Try that out as a new format for us. So Hjelte, 5G. We have had a number of Gs before the 5G, and we know that telecom communication in general has been instrumental in transforming the society in the past. But tell us, what is 5G and how will it continue to transform us, and how does it even differ from the Gs that we had before?
Yeah, so 5G is a new generation of the mobile technology, and it's an evolution of these mobile technologies. The interesting thing about 5G is that it contains some real technologies for us, for the Internet of Things, not just for the Internet of Humans, for the Internet of Things. And it allows us to actually use the network in the way that's best for the use cases, and we'll come back to that later, instead of that the network just gives us some kind of network quality and then we have to live with that. So it's giving us more control. There are three elements in the 5G, and they are all part of the 5G generation. The first one is the massive mobile IoT. So there's a lot of energy efficient sensors and electricity meters and these kind of things, and they're located, for example, in buildings or even they're traveling around as wearables, very power efficient, and these will be massively deployed in 5G. And that's a continuation of what we already started our journey in 4G. We'll come back later to that, what 5G has to offer and how that's different in 5G compared to 4G. Of course, it's also more data, and that is a lot of what we are reading about in the consumer market. People like to stream a lot of data and so on, so it's more data. But that's perhaps more also for the Internet of Humans. For the Internet of Things, there's a third very new and innovative technology, which is providing us a very fast and predictable feedback. So if we're sending data communication, oh, sorry, we had some technical issue there, but
that was feedback, actually.
There was some feedback. Yes, that was an example, but exactly live what we need. Yeah. Live example that we got a response back, and you saw it take a little bit time. So if you have collaborating robots, for example, then they are working together on a product. Then you can very fast feedback. So these are the three, let's say, basic blocks of 5G.
Very good. So, but all this sounds great, of course. Then again, this is a webinar that we're broadcasting mostly on behalf of our customers, which are the enterprises, the ones that we really want to allow utilize the technology as such. But from an enterprise perspective, what's new with 5G? What's not possible to do with 4G that you can do with 5G?
The difference is basically in that, IoT is not, there is not just one type of IoT. There are different type of IoT cases. Mm-hmm. For example, from this, I give you the example of these wearables or let's say the sensors, but we also have, IoT things like self-driving cars, collaborative robots needing this very fast response. So those are two things. And there are some improvements in the IoT, but a lot of people, they're talking about the self-driving cars as an example of the 5G.
But will that actually happen? I mean, self-driving cars, it's been science fiction for a while, of course, so do you think it will be real?
Well, we, of course, know if exactly self-driving cars will be happening, but look at 1982. I mean, we are old enough perhaps to remember, they always ask us old guys to do this kind of presentation, right? Then in the 1980s, we have Michael Knight with Knight Rider.
Oh, yeah, I remember.
Yeah. Go to YouTube, you can look at the first episode, you see he's driving around in a car, and the car reads the signs and gives him navigation and talks to him, and he talks to the car, he says, what's this, a driving car? Are you crazy? Oh, better listen to some music, and the car starts playing music. And in 1982, we were laughing about that. I said, haha, this never happens. But I just drove here to office. It was nice actually to go to office for a while instead of working from home. And I come to office and the car does all that for me today. And that is reality. That's not anymore science fiction. So it's very important. Also, we have 5G will, like 4G has has done before, transformed society. So when you look, for example, what Schopenhauer said in the 18th century already, and if you have here some person who has seen a transformation from the 18th century, it was Schopenhauer. So in the very beginning, when we come to something, we have some different phases. So in the beginning, we see something, it's like self-driving cars or this kind of collaborative robots. Does it make sense? It's ridiculed. And then afterwards, people start to think, it doesn't really work, it's not safe, it's not secure. And then after a while, it's self-evident. Then we all take it for granted, like I drove with my car this morning. So yes, we are getting there, Martin.
Very good.
So
very good. But okay, so we talked about now self-driving cars, Michael Knight, philosophers.
Oh,
if we get back to 5G now and the topic, what can actually enterprises do with it? I think that was the question I asked.
Yeah. I have the tendencies to fly away, but actually, so what can you do with the 5G and when will it come? So it's very important with 5G to look ahead at the things that actually you can do with that in the future. And one of the things that we are doing with 5G is that we give a better network exposure, so that it's easier to actually reach these energy efficient devices. And we're allowing the network actually to give a better predictable answer by using a new concept in the network we call network slicing. We can come back later to that.
Very good. So okay, so all this, I guess it in one way or another gives enterprises better control of their IT services and how they can use. But can you expand on how that is done, maybe?
Yeah, so that is actually sometimes called programmable as well. Look at it from how we started with the 2G and the 3G. Then we have an automotive use cases. We have cars. They started to connect the network, and they used the network that was available. It was not designed for that. It was designed to make voice calls, to send SMSs, and then it was, let's also do that. So then we used that what was available, very pragmatic. But in the 5G, the device is asking the network what kind of quality it will receive. Would it like to, for example, be very energy efficient and therefore less responsive, or must need to be ultra fast response? So here there is something that sometimes the device is programmable, or we actually have specific functions in the network that make the quality of the network better and faster.
Okay, so it sounds like actually with 5G we'll also have networks then that maybe are more built for purpose of IoT from start.
Yes,
that's excellent. So, but how will it happen?
Yeah, so this is, now again, we have to talk here, we are here in an IoT community. From an IoT perspective, you know, the 5G, it is actually happening, but we are not there yet. Like also these three phases of Schopenhauer, we also have three phases here. We first, in the beginning, are in a transit phase where we are seeing some 5G popping up here and there in cities, for example. Here in Stockholm behind us, there is 5G, but not everywhere in the country yet. Then the second step, we will evolve, there will be 4G, 5G everywhere, and then the last step is we will transfer. So we start with the transit phase. And in the transit phase, the very first version, that's where we are right now. So what we have done at Telenor, we have looked at all, let's say, partner networks in Europe and North America, and we actually checked on the website to see where their 5G actually is. And you see that basically in all countries they have started in cities, the major cities, and not yet nationwide. But why is that actually? Why do they start in cities, Martin?
Oh, you're asking me now.
Yes.
Yeah, you know, I think the simple answer to that is that in the cities, that's where the not of humans typically are. That's where we go around with our handsets. That's where we are utilizing the mobile broadband to a large extent. That's where we operators need to expand the capacity. And of course, 5G is providing new functionality for IT, but it's also expanding the possibilities of operators to utilize new spectrums and so on that we will need to just keep in the growth phase of mobile telephony as such. So from these reasons, we typically start in the urban areas to build for capacity, but eventually the 5G network will be rolled out in rural areas as well and be more nationwide available. It will take some time. I think in this this transformation of operators, we will also see that some legacy networks will have to be turned off to give room for 5G, meaning that 3G is probably in most markets one of the first technology that will be discontinued, but eventually also 2G. So this is something that we all need to, of course, prepare for. But at the end of the day, it's for the purpose of freeing up spectrum that we can use for more efficient and capable networks like 5G, actually. But that said, I don't think that we need to be so afraid that 4G is being turned off in the coming time, right, Hjelte? I think that will be around.
Yes, 4G will be around. So here's also 5G different from before. I mean, 4G was there to replace 3G and 3G to replace 2G. But 5G is actually technology-wise more able to work together with 4G, and especially for the IoT part. There are two examples. You know, we talked last year about LTM and narrowband IoT technology. That is part of the 5G family, but it is actually introduced in the 4G area. But it will be available in the 5G lifecycle. So we have a network that has been standardized from the start to make sure that 5G and 4G work together under the whole lifecycle. Second example, how operators are doing that, they use things like dynamic spectrum sharing that allows 4G and 5G to work together at the same time and the same radio frequencies. But perhaps that is not so relevant for our customers to see how the radio frequencies work.
Maybe it's more relevant for us, actually.
Yeah.
But rest assured, we'll take care of that for you.
Yeah.
So that's fine. But you say that 5G then will be introduced. It will be running alongside 4G to a large extent. But will it evolve?
Yes, of course it will evolve, but it's important to, during the transit phase as an enterprise, it's very important to not get stuck in this transit phase and think about Schopenhauer and think 2 steps ahead. Because the evolve phase will happen, we believe, in Europe, 2023, 2025, depending on country. So we have, we have a little bit of global vision here from our background here from that part of Telenor. So from, let's say, that will be 2023, 2025. So it's already important to start to look ahead for a world where there is 5G and 4G together. So in the evolve phase, this will be a new phase. In a couple of years, there will be 5G and 4G everywhere. And it will also work in the countryside. And what does it mean for enterprises? Well, we see that still a lot of our customers are using 2G and 3G technology.
True.
And that is based in a different way. The first time I used internet, it was more than 20 years ago, in 1995 or something like this. I was a student and I lived in a student house, connect with my modem to the internet at night because I shared a phone line with 20 other people. That kind of technology, I'm getting a little bit old here, of course, but that kind of technology is 2G, 3G. The 4G, 5G, or 5G, 4G, I should say, is always online. So you should actually think about re-architect your applications that way. For example, it becomes a bit technical perhaps, but we see a lot of customers sending SMS or even voice to wake up a device that connects to the internet, like I did when I was a student, send some data and disconnect. You need to think about this always online kind of possibilities that will make your use cases much more robust. So this is something that actually will make existing use cases much more robust with higher data rates, but also to be always available online.
Which of course sound promising now that we are moving into even more things connected, and I think that IoT getting integrated in business critical applications to an even larger extent than before. So of course, the robustness that you're talking about is great. But we mentioned it's an evolution, right?
Yes.
Is that all that it has to offer 5G, or will there be any radical changes that comes in play as well?
Actually, and I've heard also others saying that this is not yet a real 5G. I mean, this is not yet a real benefit, because this is just what you can do today already done a little bit better. Now, the real things that 5G has to offer are 2 different things. The first thing you see here on the slide is network exposure, and that's a very important thing for the IoT, and also the local network. So there are many more things that 5G has to offer, but we believe from your perspective as an enterprise, these are the 2 major things that you can actually benefit from. And the first thing is network exposure, and that has to do with the following. we have a lot of these kind of devices. They need very long battery life, and they are used in very deep indoor locations. So they are not very fast, but they are very efficient. You know what is the most efficient IoT device?
No, but I have a sensation you will tell me.
Yes, haven't we practiced this before? We perhaps this becomes a little bit. The most efficient IoT device is a sleeping IoT device, because IoT device is always connected, but also sleeping. So
to save power.
To save power,
yeah.
Because the battery life can be 10 years or more. And how do you actually then get data from this device when it's sleeping? It will not respond. So the first thing you might think, a lot of people think, I send an SMS to wake up the device, but that's not the way how we work in 4G and 5G. You can do it, but it is not, it's not an efficient way. So what you do instead is you use a network exposure function in the 5G that can help you to actually bridge between that device that's actually online but sleeping, so not reachable, and the cloud. In the cloud, you expect things to always be online and connected. You have a dashboard, for example. You're working in a healthcare application. You have a dashboard of a building with all the humidity sensors in a dashboard. You would like to have the latest value. That value might be, 15 minutes old because the device is sleeping 15 minutes and then wake up again. That's completely fine. But it actually, you have to have the data in the dashboard. So network exposure function helps you with this. But that's not the only thing.
But just to say, what it means then is that from the application side, your enterprise applications, you have the sensation that your IoT devices are constantly online because you know what kind of latest value, and then if you need to refresh that, the network will take care of it in an automated way and wake up the device, ask for a new value when it's needed, and then bring it back. Is that
so it will also cache the data. So there are different mechanisms in here. We here touch just upon the surface, but this whole topic of this network exposure is a fundamental change, because this is an exposure function for IoT devices. So it just means that the data is always there, and because in the cloud we expect always to be connected. I look at our children; they expect always to be connected. This is the modern age. But the devices are efficient; they're not always connected, and they use also very efficient protocols, because they use a kind of very efficient protocols to reach further into buildings, for example, and to save even more battery life. Also, there are a few things we are doing there. One of the things has to do with the security, and to explain security, security is important because everybody wants to have secure communication to devices. And of course, we can do that very well in mobile networks today, in 4G and also other generations before. We can do that. But the security functions of the internet, that is the cloud side of things, that one is not the most efficient because it uses a lot of overhead. So, for example, I give you, there's something called certificates. So let's say a certificate is a kind of like a business card. If I have a communication with you, I can first give you my certificate, and we have both certificates that I know you are you and me. Then we can create a secure channel. The certificate needs to travel over the network, and there's no problem in the cloud. But on the left side of the picture, where the very energy and efficient devices are, this can be trouble. And that's why this network exposure feature actually it handles this certificate. So the certificates are in the central place. All the internet communication to the cloud in the cloud is doing the secure communication with the certificates, just as you use any other device. But on the left-hand side, we use the 5G operator secure functions to make sure that the communication is secure and as well efficient at the same time. And this has been really a problem. Not having this has been a problem to really get out LTM and narrowband IoTs. We think this will push. There is another thing we have last year. People have seen this one before. You can also see still this webinar. Last year we discussed about narrowband IoT and LTM, especially for global deployments. We're seeing that LTM, if you have to choose between the two, LTM has better cards, it has more possibilities because narrowband IoT is very much limited. Sure. One of the things that actually the network exposure helps narrowband IoT especially with is the software update part. So also managing software updates of narrowband IoT devices is now more done in a standardized and more in easier way with network exposure in the 5G. So here is something that you don't read so much about because it's not for the consumer market, it's really for the Internet of Things. A typical example of how we can easier connect the cloud to the devices without going into all the telecommunication details needed that you need in order to have the communication secure and efficient.
So in essence, it's like taking more of an internet approach to the communication rather than a telco approach. Is that what you're saying?
Yes, without
overhead. We talk about APIs and,
yes,
and things that people are used to work with actually from the internet world more than having to know deep dive telco protocols.
Exactly.
That's good. I think that will make it easier for the enterprises. Very good. But now, you've been talking about a lot of things here about 5G. It's battery lifetimes to manage devices that sleep a lot. We talk about self-driving cars, which is maybe a completely different thing. We don't want them to sleep. So how can we manage all these at once? Can we?
Yeah, how can we manage them all at once? So it is very correct. If you, for example, have collaborative robots that do precision engineering together in a factory where now there's a lot of people are working, and to increase the productivity, when you have at some of these places robots that can do precision engineering, two of them, they communicate very fast with each other at the same time, or self-driving cars, they definitely should not sleep. So you should not use those technologies at the same time. That is very important. So it's a choice here, yeah. But of course, for this very fast and predictable, we must make sure that that is very fast and very predictable. We actually have some additional thing which we call local networks. And then, of course, people say, yeah, but what is the mobile network not predictable? Now, I think the mobile network as we have it today is already very predictable. You actually can do quite a lot of things. As a matter of fact, part of the stuff that's going on here right now is using the streaming on 4G. So actually, the mobile network is very good, but it's always a kind of best effort. And especially when data needs to travel a very long time, it can actually take some time. So there are two things you want to do there. First of all, you would like to bring the data close to the device. So if you see this picture on the left-hand side, you see some robots and machinery that communicate with each other. They don't want to communicate and say, okay, I ask robot number one, ask robot number two. I'm going to send all the data all the way to, let's say, a central cloud and then back, because then it becomes there. It will be a little bit slow, and also, yeah, there is a lot of other factors there. So you keep the data local where needed. So in order to do that, there is something that they call network slicing, and that is actually, for those new to the concept, if we look at software, what do we do with software development? If you are a CTO of a company and you develop a piece of software, right? Yeah. So are you going to buy a data center and put your software in the data center? Not anymore. I think we are moving at least a lot of things to the cloud. Sure. So why do we do that to the cloud? Because the cloud gives us the possibility to scale very fast. So we can start small and scale fast. So it's a cost saver. We share a lot of, let's say, infrastructure because you get it from a cloud provider. But we still have some isolated parts because we share the resources, but we don't want to share some things with other players in the cloud.
We want to keep it isolated from.
Yes. Yeah. So this isolation in the cloud technology, there have been a lot of developments there to make this happen, and that kind of technology is now available in 5G networks as well. So if 5G networks have the possibility to, let's say, there is a kind of part of the network. You say this part of the network we use for IoT, but not for all IoT. This part of the network we use for IoT for this factory. And by doing that and putting more data and more, let's say, also radio things local, we can have a much more predictable and fast responses. And that will work. That will, again, not replace what we're having. It will enhance what we're having. Because, of course, on the right-hand side, for the most cost-efficient use cases and for many IoT use cases we have, the best effort is actually really, really good, but not for the self-driving car. So there will be this kind of combination of technologies.
So basically what you're saying is that there's a possibility to get dedicated resources in the network for an enterprise or for an application or for IoT as general. We can scale that up and down if needed, but it comes at the cost of some sort, of course, because you're actually reserving
yes,
capacity in the network for a specific case. And then we will on the side also be able to open up the pipes and have the best effort for maybe most of the use cases. That would be good enough.
Yes, I think for a lot of use cases, and especially again, we said about those different phases, the ones that were evolving, then I think then best effort is really will be good enough for quite a long time. But we should not forget that this technology will evolve. This will be, very commonplace in 5 years from now. So then there will be a lot of new things happening over there.
Well, all this, I mean, it sounds fantastic. As a tech guy, of course, you like the technology as such. It's very interesting. Can we do anything with it? Any practical things? This is a difficult question, I know. I mean,
yes.
we've been quite poor in predicting the killer applications in
yes.
each every G that we've been launching in the past. But now you get the opportunity.
Yeah, but Martin, actually, we are bad in forecasting the killer use cases, but there have been killer use cases in previous generations.
Of course.
For example, everybody is everywhere streaming, always online. That's not 5G. That is the previous generation. But when the previous generation came, did we foresee that? No. So there will be some use cases here, some things that we're talking about. And we take self-driving cars as an example, collaborative robots, and there are various others. If you look around for things that you can do with 5G. But what you can do actually with 5G, with this predictable network, is a new set of use cases. But of course, we don't know. It all has to come from, let's say, use cases.
Yes, I agree.
And
those use cases, I guess, at the end of the day, I hope that it will be some of our customers that will invent those use cases and make the killer applications utilize technology. But how do you do it?
Yeah, it's not, you cannot simply push that to our customers, Martin. That is something that we need to do together. We, as an industry, need to do this together. So it will be from us, from the operator side. There is many parts in an IoT application that could be, for example, the hardware, the communication models, the cloud. All that kind of things need to work together, and we need to create the use cases together. So we cannot tell you what the use cases are, but we can together work together to see you have ideas. How can we use this kind of technology and collaborate? Because collaborate to make those use cases, and then probably we will start with use cases that are not, let's say, the crazy use cases. We start with the small use cases, and step by step we will transform society, and then in 10 years we look back and say, oh, these use cases were the killer applications of 5G, but we didn't foresee them. No, if you can foresee the future, that is actually something that we do together as a society. But perhaps I am again fluffing away.
No, I don't think so. I mean, tell me when you know the killer application, and I will make sure to invest in it up front.
Yeah.
No, jokes aside, I think trying to summarize this, what we've heard. I mean, 5G, it's coming now. We're starting to deploy it. Maybe it will be not available globally and nationally even in the first phase, but we will start to roll it out as operators in the urban areas, and then from there get the national coverage and so on. But it starts to happen now. That's the key thing, and it will happen alongside 4G.
Yes,
which is great.
And don't get stuck in the first phase.
Exactly.
You see it and you think, what's this? No, this is just the first phase. We are in the beginning.
We are in the beginning, and from there into the transit phase that you mentioned. We get into the evolutionary phase, where we will start to enhance the 5G experience. Once it becomes more widespread and we get the functionality in place, people can start to use, or enterprises can start to use the new functionality, right?
Yes.
Making it more programmable and getting access to functions that will make the IT devices work even better than before. That's where the fun starts, I guess.
Yes, that's where we really make 5G a network, which is not, let's say, here you have the connectivity and good luck with it, and then people are inventive and do something with it. But instead, it will be the IoT use cases that actually can ask for specific kind of network capacity.
Great. And then you had the third phase, the transform as well.
Yes, that is the transform phase. So in the transform phase, we actually take the use cases that we are that we are creating together, and those use cases, they need not only technology, they need, of course, a use case, a business case. Not all of them we know right now, and this is normal, but we should together to see how we can actually build together this kind of business and use cases. So it's not something that we can do alone. It's not something that you should do alone as well. So Telenor, we already working together at this kind of partnerships, Martin, right?
Absolutely. Satellite IoT, how will 5G interact with satellite IT? Do you have a good response to that, Hjelte?
Well, satellite IoT is, we are, of course, already today having a kind of connectivity with satellite, but with satellite, we can have an additional type of use cases, because a lot of, if you look at the Earth, I mean, the places where we actually have the sea is the largest part. So having satellite integrated in 5G will enable many more use cases. Already right now, we have, of course, things that is going along ship routes with maritime and this kind of things. But when we have more 5G use cases, we can have IoT at more remote locations where it's actually perhaps very expensive to send somebody to monitor a system. It's better to do that kind of things remotely.
Yeah, I agree. Now, I think that at the end of the day, it's about finding the right technology for the right use case, right?
Yes.
Because we also have, I mean, we shouldn't forget about it. We have Wi-Fi technologies, yes, and we have Bluetooth and what have you. So, I mean, there are different ways of connecting things, of course, and I don't think that it's one technology that rules it all.
No, that's also some people say, for example, what happened is 5G going to replace Wi-Fi? Absolutely not. So 5G is a mobile connectivity technology that has certain kind of advantages that you have a kind of, then you need to look more at the management of things. We manage things more centrally, while a Wi-Fi is more often a decentralized solution. So you locally have to connect things, pair them, etc., instead of having that security on a more central way.
Those self-driving cars that you talked about. Yeah. Is it only about the technology to see that happen, or are there other aspects for such a use case to really fly? I mean, so from society perspective.
Yes, I think from society perspective, of course, there are more things that are needed for that to fly, and I think then becomes perhaps a little bit philosophical, but it's also very much an acceptance thing. We need to then look ahead and. Of course, there are many aspects involved into self-driving cars. One of the aspects are, of course, kind of thing or legal things, but also is a kind of awareness and trust in the technology that we believe that a human makes better judgments than a car. I already have seen with my half self-driving device, it's not completely automated. It braked one time. It saw some cars in front of me earlier than me, and then I thought, well, quite good.
It works. Yeah, I agree. So, it's fantastic. We have a question here as well regarding this always on that we talked about coming into play with 5G. Can we expect that not only from a power management perspective, but from a network perspective? Do we have the capacity in the networks to have all these devices connected at all times?
Yeah, so the standards have from the very much start have been designed for doing that. To have this large amount of devices of a little bit simpler nature that perhaps don't send huge amounts of data all the time at the same time, but have that. So it has been in all the standards and all the steps has been there as this massive mobile IoT as one of the 3 cornerstones of 5G. So it has been there, and that's very different than, you know, in 2G and 3G, it just thought, oh, there's data you can do, oh, you can send some data. Like it's an afterthought. But this is a design, so it's by design it's there. So yes, there's capacity.
Very good, promising. We have a question here. If we as Telenor Connexion are planning to, as an MVNO, then offer network slicing and so on in other operators' networks, I think that is an interesting. Maybe I should take
a question for the CTO.
I guess yes. So. I think here actually the industry is also still learning and understanding how we can develop those business models, because at the end of the day, I think technology is one thing, business model are another thing. So right now, as most of you might know, of course, we have established systems for utilizing other operators' networks with roaming, and we have the ways to manage that from a commercial perspective between each other. I think similar setups need to be in place then between operators to secure that we have access to the capacity in an SLA that matches the requirements and utilize this slicing concept all the way out. I dare to say that we're not there yet, but I really hope that we as an industry will allow for it, because for international use cases, it's of course the key to make the concept of network slicing available on global scale. So unfortunately, I don't have the answer on how we're going to do it, but it's something that we need to jointly as an industry work for, and there are work groups for that, part of our global forums, the GSMA. And,
yes, the GSMA. Yeah. This is one of the topics that's being discussed. So that's not that's also something for the future. But the 5G technology stack is prepared for this kind of things.
It is. It is. Then a question here we have about outdated wake-up mechanisms, SMS and voice call that you mentioned, Hjelte.
Yeah.
How do you concretely design an LTM-compliant wake-up mechanism, which is optimized for power consumption? How do you do that?
Yeah, perhaps we have not so much time, so I will bluntly say I would not design a wake-up mechanism. I would let the use case steer the connectivity, not the connectivity steer the use case. So the application should actually be in sleep mode, and the device knows when it goes out and in out of sleep mode. So you have that logic in the device, and the device will tell the network, here is some data. So then it can, for example, sleep a day or a week if you want. Might be a little bit tricky week, but that is possible in networks. So it can sleep for a day and then send some data and then go back to sleep for the most efficient one. But it's very important to understand also LTM and narrowband IoT is not a one-size-fits-all. You can ask different levels of sleeping. So you can say, I like to sleep for an hour, I like to sleep for 5 seconds. Sometimes sleeping 5 seconds instead of listen every second under a life cycle of 10 years can quite save some time. So there's a lot of stuff there, but I will not go into detail. The bottom line is, don't ask the devices to wake up. Instead, put that kind of logic in the devices and let them send to networks. That is, in general, how LTM and narrowband IoT have been designed. And then with a network exposure function, these kind of problems actually are going away, because it's much easier to go through a network exposure function when that is available.
Very good. There will also, I should say, be a white paper released on this topic quite soon.
Yes.
So we'll go through the same things, but maybe expand on some things as well. So watch out for that. But with that, Hjelte, thank you very much for sharing. And all of you who tuned in, thank you very much for tuning in. And let's meet up and see each other soon again. Thank you.